Hello and welcome to the next session of the module number 3, which is analysis of force system. In the previous sessions we had discussed about the concept of idealization, force system, characteristics of force system, then the resolution of the forces, resultant of the force system, composition of the force system, and some numericals on how to resolve the given force system. Let us continue with the next session. So, the next problem goes like this: a force F1 equals to 1200 Newton is acting vertically on an inclined plane as shown in figure. Find its components along x and y axis. So, this is the problem given. Let me draw the figure. So, this is the figure given. We need to find the x and y components of this force, and if you observe this, the angle of inclination theta is not given, but slope is given. You need to calculate the value of theta by taking this right angle triangle and then resolve the force and find its x and y component. Okay. So, first let me solve the value of theta. So, this is theta and this is 3 units and 4 units. So, what trigonometric function can we use? We can use tan function. Tan theta is equal to 3 by 4 opposite by adjacent, or theta is equal to tan inverse of 3 by 4, that is equal to 36.87 degrees. So, this is theta. Now, let us resolve the force and calculate the x and y component. Now, this angle is nothing but 36.87. This is the force acting 1200 Newton. Now, let me project this line so that this will be exactly perpendicular. This is nothing but a right angle triangle. Now, if this is theta and this is 90 degree, what about this angle? It is 90 minus theta. 90 minus theta, which is nothing but 53.13 degrees. This is the angle 53.13 degrees. Now, here this is the x axis given, this is the y axis given. If this is 53.13, what about this angle? This is also equal to 53.13 because vertically opposite angles are equal. Next, this is the angle of inclination which this force of 1200 is making with respect to its x component. Okay? Now you need to resolve this force and calculate the x component and its y component. So, x component is nothing but fx equals to f cos theta, where what is fx? It is fx equals to 1200 cos 53.13. Now let me write the result force. So its x component will be written as shown, and its y component can be written as shown. This is fx and fy. So, since it is measured towards right, the positive sign should be considered for fx, and since y is measured upwards, the positive sign should be considered for y component also. So, what is 1200 into cos 53.13 equal to? 720 Newton. I hope we have written the arrow in a wrong direction. Since the force 1200 is acting towards this point, we also need to write the arrowhead of fx towards the same point. So, this is fx. Here change the arrowhead. This is fy. Now, the sign convention for fx is minus because it is measured towards left. Minus 720 Newton. Similarly, if we try to find its y component, fy is equal to minus fx sin theta, that is equal to minus 1200 into sin 53.13, which is equal to minus 960 Newton. So, fy is equal to minus 960 Newton, fx is equal to minus 720 Newton. This is how you are going to calculate the x and y components of the force system given in this particular problem. Okay. So, this 1200 Newton force is acting downwards, and hence you need to write its x and y components as shown, and corresponding sign convention should be taken into consideration. And then when you try to resolve, this 53.13 will be the angle of inclination which this force may with respect to the x axis or the horizontal. Okay. Next, calculate the fx value and fy value as shown. Clear? Okay. Now let us move on to the next numerical. Resolve 400 Newton force acting on a block as shown in figure. Into two components as given below. The first case, horizontal and vertical components. Second, along the inclined plane and right angles to the plane. Okay, now let me write the figure. So, this is the figure given. You need to find horizontal and vertical components of the 400 Newton force, and also you have to find the components along the inclined plane and right angles to the plane. So, this is the plane. Need to resolve this 400 Newton force and calculate its horizontal and vertical component, and also the component along the inclined plane and also right angle to the inclined plane. Okay, let us see how we can calculate this. So, the first one, horizontal and vertical components. Okay. Now, you need to find the angle of inclination with respect to the horizontal axis first. In order to resolve this 400 Newton force, to find its horizontal and vertical component, you need to determine the angle of inclination which that force is making with respect to the horizontal. Okay. So, here we have this force which is 400 Newton, and the inclined plane is having 20 degrees and the force is inclined at an angle of 30 degrees as shown. This block is inclined at an angle of 20 degree with respect to the horizontal, and this force is inclined with respect to 30 degrees with respect to this line. Now, what will be the angle of this 400 Newton force with respect to this horizontal? Okay. So, that needs to be calculated first. So, this is 20 degrees. So, now from this figure I can write this figure based on the angles given. Now, you need to determine what is the angle of this 400 Newton force with respect to the horizontal. Now, if I just draw a horizontal line here, what is the angle with respect to this 400 Newton force? That is the question. So, now if you observe, this is 20, this will also be equal to 20, but I need to calculate it with respect to this force. So I need, or if I continue this line, if this is 20, this is also 20. This is 20, this is 20, opposite angles are equal. I need to determine this angle only, because I need to measure the angle with respect to the horizontal. So that will be nothing but total is 30 and this is 20. So this will be equal to 30 minus 20 degree, which is equal to 10 degrees. Okay. So the force which you are going to consider is 400 Newton with respect to the horizontal angle is 10 degrees. Now if you try to resolve this, you can resolve this as Fx and this as Fy. This becomes the horizontal and vertical component of 400 Newton force. So its horizontal component Fx equals to, it is measured towards right, so the sign convention is positive, plus F cos theta, which is equal to 400 cos 10 degrees. The value is 393.92 Newton. This is the horizontal component. Similarly, its vertical component can be found out. Fy is equal to, Fy is measured downwards. So the sign should be minus F sin theta, which is equal to minus 400 sin 10 degrees, which is equal to minus 69.45 Newton. So this is the x and y component, or the horizontal and vertical component of 400 Newton force. Please understand, this was the block given, and the angle of inclination of the block with respect to the horizontal is 20 degrees, and the angle of inclination of this 400 Newton force with respect to the inclined plane is 30 degrees. So using this, I have drawn the second figure wherein I have written various angles, and I came to know that the angle of the 400 Newton force with respect to its horizontal axis is 10 degrees, and correspondingly I have resolved the forces and found out the values of Fx and Fy. Similarly, we need to resolve the same 400 Newton force with respect to the inclined plane, which is parallel to the inclined plane and perpendicular to the inclined plane. Okay. Now, second one, along the inclined plane and right angles to the plane means perpendicular. So first, along the inclined plane, if I try to write this force of 400 Newton, so this is the angle of inclination of the force 400 Newton as 30 degrees. So this will be along the plane, inclined plane. So, based on the arrowhead of the 400 Newton force, I can write this and try to find the x component as Fx acting towards right. Next, similarly, if I try to write its 90-degree or the perpendicular component, one is along the inclined plane, the other is perpendicular to the inclined plane. So, for this line I can write this as the perpendicular line. So, this is Fy, where Fy is measured downwards. So, you can now resolve this. Fx is equal to, that is along the inclined plane, 400 cos 30 degree, and it is measured towards right, sign is positive. That is, I can write Fx equals to F cos theta 400 cos 30, that is equal to 346.41. This is along the plane, along the inclined plane. Next, you want to determine the component which is perpendicular to the inclined plane, or that right angles to the inclined plane, that is Fy is equal to minus F sin theta. Why minus? Because it is measuring downwards. So, that is equal to minus 400 sin 30 degrees, which is equal to minus 200 Newton. So, this is at right angle to the plane. So, this Fx and Fy is different than the previous Fx and Fy. In the previous case, Fx and Fy was the actual horizontal and actual vertical, but here the Fx is along the inclined plane and Fy is perpendicular to the inclined plane, or at right angles to the inclined plane. Okay? So, I hope you now have an idea about resolving the forces when the forces are acting on an inclined plane or an inclined body. So, when the body is inclined at an angle and the force is acting on a body, then how do you find its x and y components? So, the previous two problems give you a clear picture about the resolution of forces when the forces are acting on a body which is inclined. Okay. So, next we shall move on to the finding out the resultant of various force systems. Okay. How do you determine the resultant of the given force system and also determine its angle of inclination with respect to the horizontal. Okay. Next, determination of resultant and its inclination with respect to x axis. So, you know the formulas and we can use the formulas appropriately when we take up the problems. So, the first problem under finding out the resultant goes like this: determine the magnitude and direction of the resultant of two forces if the angle between the forces is 30 degrees. This is the question given. Please try to understand. Determine the magnitude and direction of the resultant of the two forces of magnitude 12 Newton and 9 Newton acting at a point if the angle between the two forces is 30 degrees. So, here they have given you two forces which are acting at a point, and the angle between those 2 points is given as 30 degrees. You need to determine its magnitude, which is the resultant, and the direction, which is nothing but its inclination. Okay? So, I had written some formulas with respect to the resultant and its inclination. If you have two force system, we have to apply the parallelogram law of forces. Okay? And if you have forces more than 2, then we can apply the other formula. Now, let us see how this problem goes. So, let the first force be F1 equals to 12 Newton, and let the second force be F2, which is equal to 9 Newton. The angle between the forces, which is theta, is given as 30 degrees. So, using this data, try to plot the figure. So, there are two forces, F1 equals to 12 Newton and F2 equals to 9 Newton. F1 is equal to 12 Newton and F2 is equal to 9 Newton, acting at a point. So, let me take this point as point O. The angle between the two forces is given as 30 degrees. Now, please observe this combination of F1 and F2 can be taken to construct a parallelogram. We can easily construct a parallelogram and apply the parallelogram law of forces. Okay? So, now this looks like a parallelogram. After applying the parallelogram law here, we can determine its resultant R, which is nothing but its diagonal. Okay. So, now since this completes a parallelogram, I can directly write the formula of the resultant. So, here resultant R, let the resultant be R and alpha be the inclination. Now, the magnitude of the resultant is given by R is equal to square root of F1 square plus F2 square plus 2 F1 F2 cos theta. So, this is from the parallelogram law of forces. Now, if we substitute the values of F1 and F2 and theta, so F1 is 12 square plus 9 square plus 2 into 12 into 9 into cos of 30 degree. So, this will be equal to 20.3 Newton. This is the magnitude of the resultant R. Now, we need to calculate its inclination or the angle of inclination. So, the direction of the resultant alpha equals to tan inverse of F2 sin theta divided by F1 plus F2 cos theta, that is equal to tan inverse of F2 is 9 into sin 30 divided by 12 plus 9 cos 30 is equal to 12.80 degrees. So, the direction of the resultant, which is alpha equals to 12.80 degree, is with respect to x axis. Or the horizontal. So, this is how you determine the resultant R and its inclination alpha. Since we are having only two forces, we can easily apply the parallelogram law of forces here. So, using the parallelogram law of forces, I have calculated the resultant R and its angle of inclination alpha. Okay. I hope you have understood this problem. Let me move on to the next problem. Find the magnitude of two equal forces acting at a point with an angle of 60 degree between them, if the resultant is 30 root 3 Newton. So, in this case, they have asked us to find the magnitude of two equal forces which are acting at a point and the angle is 60 degrees between them, if the resultant is 30 root 3 Newton. In this problem, we have the resultant R, but we need to find the values of F1 and F2, which are said to be equal. So, here F1 is equal to F2 is equal to F. So, let the forces be F1 equals to F2 equals to F. Because the forces are equal, let the forces be F1 equals to F2 equals to F, and theta is the angle between the two forces. So, if I try to plot the diagram, I can write F2 is equal to F, F1 is equal to F, angle between the two 60 degree. In this problem as well, we have two forces, so that we can easily apply the parallelogram law of forces, and hence let us calculate the values of F using the same law. Now, using parallelogram law of forces, we have the formula for R given by F1 square plus F2 square plus 2 F1 F2 cos theta. Here R is equal to how much? 30 root 3. Let me write it here. So, this is 30 root 3 is equal to square root of, what is F1 equals to? F, that is F square plus F square plus 2 into F1 is also F, F2 is also F into cos 60. Okay, that is equal to F square and F square, it is 2F square, it is F square and F square, 2F square plus 2 F square into cos 60 is nothing but 1 by 2. So, this 2 and this 2 gets cancelled, we remain with square root of 3 F square. Here we have 30 root 3. Now, what can we do? We can square on both the sides, that is squaring on both the sides, we can cancel this square root. So, I can write squaring on both sides, we get 30 root 3 whole square is equal to square root of 3F square whole square. Now, I can cancel this square and this square root. Okay. Now, let us try to expand this. 30 root 3 whole square, that is 30 square into root 3 whole square, to square root and square gets cancelled, that is equal to 3F square. Now, 30 square is 900 into 3 is equal to 3F square. Here we have 3 and 3 on both left hand side and right hand side, and hence I am cancelling it. So, I can write F square equals to 900 or F is equal to square root of 900. We know what is the square root of 900? Yes, we know that the square root of 900 is 30. So, the value of F which we want to determine is 30. Now, if F is 30, what had we written in the initial stage? That is F1 is equal to F2 is equal to F. That means F1 is equal to 30 Newton, F2 is equal to 30 Newton. This is the final solution. I hope you have understood this. Okay? Now, let me move on to the next problem. So, next problem, the resultant of two forces when they act right angle is 10 Newton, whereas when they act at an angle of 60 degree, the resultant is square root of 148 Newton. Determine the magnitude of two forces. So, this is the question given, please try to understand. The resultant of two forces when they act at right angles is 10 Newton. So, when there are two forces acting at right angles, the resultant is 10 Newton. Whereas, when they act at an angle of 60 degree, the resultant is square root of 148 Newton. Determine the magnitude of the two forces. Okay. So, let me start. Let F1 and F2 be the two forces when theta is equal to 90 degree, resultant R is 10 Newton. This is first case. When theta is equal to 60 degrees, resultant R is root of 148 Newton. Okay. So, you need to determine the magnitude of the forces F1 and F2 when the cases are as given. Now, we need to write the equation of the resultant accordingly. So, we have two cases wherein we know the value of theta and R. We need to substitute R for theta 90 degree and we need to substitute R for theta is equal to 60 degree and then calculate the F1 and F2 values. Okay. So, case 1, when theta is equal to 90 degree and R is equal to 10 Newton. In this problem, we have again only two forces. That means we can easily apply the parallelogram law of forces. So, we know R is equal to square root of F1 square plus F2 square plus 2F1 F2 cos theta from the parallelogram law of forces. So, R is equal to 10 F1 square plus F2 square plus 2 F1 F2 cos 90. So, what is the value of cos 90? It is 0. So, the whole term will become 0, that is 10 is equal to square root of F1 square plus F2 square plus 2F1 F2 into 0. Okay. So, that is 10 is equal to square root of F1 square plus F2 square or squaring on both sides. We get 10 square is equal to F1 square plus F2 square whole square, square and square root gets cancelled. So, f1 square plus f2 square is equal to 100. Let this be equation number 1 obtained from the first case. Now let me write case 2. When theta is equal to 60 degrees, R is equal to root 148 Newton. So we have R is equal to square root of f1 square plus f2 square plus 2 f1 f2 cos theta. So without repeating the equation, I shall proceed further. That is equal to f1 square plus f2 square plus 2 f1 f2 cos 60 whole root. What is the value of cos 60? It is 1 by 2. So square root of 148 equals to f1 square plus f2 square plus 2 f1 f2 into 1 by 2. 2 and 2 gets cancelled, that is equal to f1 square plus f2 square plus f1 f2. So here we have square root of 148. Now on squaring on both the sides, we get square and square root gets cancelled, square and square root gets cancelled on both the sides. So we are left out with 148 equals to f1 square plus f2 square plus f1 f2. So can we simplify this? If you observe equation number 1, what is equation number 1? f1 square plus f2 square is equal to 100. So using this in that particular equation, we can write, replace the f1 square plus f2 square by 100, we get 148 equals to 100 plus f1 f2, or f1 f2 is equal to 148 minus 100, that is nothing but 48. Let this be equation number 2. Okay. Now what can we do to simplify? See, if you think to add equation number 1 and equation number 2, that will be f1 square plus f2 square plus f1 f2 is equal to 148. But if this term had 2 written before f1 and f2, we could have easily substituted f1 square plus f2 square plus 2 f1 f2 as f1 plus f2 whole square. Okay. But since we do not have 2 f1 f2 in that equation, let us multiply the entire equation number 2 by 2. So multiply equation 2 by 2. So we get 2 f1 f2 is equal to 96. Now this will be equation number 3. Now think of adding equation 1 and 3. Adding 1 and 3, we get f1 square plus f2 square plus 2 f1 f2 is equal to 196, or we have f1 plus f2 whole square is equal to 196. Correct? Now if we take the square root on both the sides, I can write, taking square root on both sides, f1 plus f2 whole square and square root of the same, square and square root gets cancelled, which is nothing but square root of 196, nothing but 14. So, F1 plus F2 is equal to 14. Now, let me continue here. So, we can write F1 plus F2 equals to 14 Newton or 14, say equation number 4. Now, can we substitute this equation 4 in any other equation in order to get the values of F1 or F2? So, substituting equation 4 in equation number 1. So, that is after simplification I can write F1 is equal to 14 minus F2. This shall be equation number 4. So, F1 is equal to 14 minus F2, F1 plus F2 is equal to 14, or F1 will be equal to 14 minus F2. Substitute this in equation number 1, we get, instead of F1, substitute that as 14 minus F2 whole square plus F2 square equals to 100, and on simplification, that is 14 square plus F2 square minus 2 into 14 is 28 F2 plus F2 square is equal to 100. So, that is nothing but 2 F2 square minus 28 F2 plus 196 equals to 100, or 2 F2 square minus 28 F2, this 100 to the left hand side, 196 minus 100 is 96 plus 96 equals to 0. Now, after you arrive at this particular equation, you need to have the necessity to calculate the roots of F2. So, you will be obtained with two different values of F2. So, after simplifying this, we get F2 is equal to 8 and 6. So, these are the two values of the F2, but F2 means it is the roots of F2. So, therefore, we can easily write that the force F1, either the first force will be 8 Newton and the second force will be 6 Newton, so that the summation of the forces F1 plus F2 will be equal to 14. Okay. So, after you get the roots of F2 as 8 and 6, we can easily write F1 is equal to 8 Newton and F2 is equal to 6 Newton. So, if you add F1 and F2, you are going to get it as 14. So, this is how you determine the magnitude of the two forces when the resultants are given for two different cases. When the angle was 90 degree, resultant is 10 Newton, the resultant was 10 Newton, and when the angle was 60 degree, the resultant was root of 148. Then, considering both the cases and applying the parallelogram law of forces, we have calculated the final values of F1 and F2. Okay, I hope this is clear.